All right, Chapter 5, Section 1, moving on to the Adept level. This video introduces something called algebra tiles. Okay, algebra tiles are simply a visual way of interpreting polynomials. Specifically, well, binomials and trinomials. Eventually they just get too complicated and tiles don't work, but at this stage we can use them. Here I have a large square, and then I call these bars. Okay, but notice that the length of the bar is the exact same length as the square. Then we have the bar with a little width here. And then we have a smaller square. And the length of that square, okay, on each side is determined by the width of this bar. So we say that this length here is x. So because it's a square, this also must be x. Therefore, the area of this square is just its length times its width, or x times x. So it's x squared. All right? So every time you see a large square like this, okay, this tile, that represents an x squared. Okay? Well, remember I said this was the same. So this is x. And then this little width here, we define that as 1. So therefore, the area of this bar is x times 1. Well, that's just x. So the area of a bar is x. And that's 1. This is 1. So the area of this square is 1 times 1. 1. So we have x squared tiles, x tiles, and we don't call these 1 tiles, we call these unit tiles. Oh boy. And notice I have another set here. It's just copied, but this one's shaded. And the reason why we have shaded tiles is so we can tell the difference between positive and negative. So if it's white, we assume it's positive. If it's dark or shaded, it's the same except it's negative. So this would be a negative x squared tile. Okay, let's put an arrow here. This gray region would represent a negative x. And the area of this little box here would be negative 1. So same size, and you're only going to have to deal with these 3 particular shapes. All right. Now, what on earth can we actually do with these things? Well, it says here, express algebraically, and I have a bunch of tiles here. Okay. Well, every time we see a large square, remember that's an x squared tile, but this one's gray, therefore it is negative. So I'll write this. So I have only one of them, so this is just negative x squared. Now I have these bars here, okay, they're white, therefore they are positive, okay, and there are 3 of them. Each of these bars represents an x tile. So there are 3 of them, hence I say plus 3x. Okay? And over here I have 2 little squares. Each square, in this case it's shaded, represents negative 1, but there's 2 of them. There we go. So in fact, this set of tiles is a visual representation of this trinomial, negative x squared plus 3x minus 2. Let's try another one. So I have 2 large white squares, 3 shaded bars, and 1 small white square. So I'm just going to express this algebraically, like this down here. All right, so I have positive 2, because they're white, x squared. Okay. I have 3 x bars, but they are negative. So this is minus 3x, and this is just positive 1. Okay, that's it. Express pictorially. So I have a trinomial here, x squared plus 2x minus 3. We're just doing the opposite. We're being given a polynomial in algebraic form, and we just want to draw some tiles. So I have an x squared tile. It's positive, but I only have one of them. So let's see here. Get my shapes on the go here. I'll do that. There we go. So I'm going to do my best anyway. Not going to be perfect. So there's one positive x squared tile, and then I have two x tiles, and they are both positive. So I have to draw two bars like that. Now, I'm going to do my best to make them exactly the same, but it's not perfect. Okay, and then minus 3, so I have to draw 3 of those little squares like that. Okay, but they're negative, so those should actually be colored in. So I'll just shade them in kind of dark here. Okay, and there we are. Next example, negative 2x squared plus x plus 2. So I need to draw two x squared tiles, okay, but I have to shade them in because they're negative. So I'll get my square back. There we are. So something like that. And not good enough. I'll do the coloring later. And then I have one x bar and then two little unit squares like that. Okay, and the width of this little unit square is the same width as this bar, and the height of this bar is the same as all the dimensions on these large squares. All right, so these ones were negative, so these ones have to be shaded in. Because they're negative. This is fun. Yay. All right. Simplify pictorially. How do you simplify? Well, look at all these tiles. I have one large square that's white, and I have a bunch of bars, but some of them are actually different color. We didn't have that last time. Now remember, when you're combining things algebraically, you're looking for like terms, if there are any. Well, you can actually do that here. What happens when you combine a positive x with a negative x? Well, they cancel each other out. And I have a positive bar here, and I have a negative bar here. So those would actually cancel out. So in fact, in the end, I'm only going to be left over with this white bar right here. There's nothing I can do with this square because I don't have another large gray square to cancel it out. You can almost think of it as the gray as being a hole in the ground, and you're trying to fill the hole. Here I have two holes, two little dark unit squares. I can fill one of them with this little white square. So these two are going to cancel out. So I'm going to circle all the ones that effectively cancel each other out. Those are gone. Those are gone. And those are gone. So all I have to do is write whatever's left. So I still have positive x squared. Okay. And I have one white bar and one little square. But the little square has been shaded because it's negative. And we're done. Next, combining all of these tiles together and simplifying them. I have a negative x squared and a positive x squared. Combining those, they're going to cancel. So I'm just going to circle them. They will cancel. I have a bunch of bars here. So that white one will cancel out this dark one. And, oh, those little squares cancel out. So I almost have a complete cancellation. I have just one dark bar left. So that's going to give me Something like that. But it has to be shaded. That's it. So as an exercise, if you'd like, feel free to do these two examples algebraically, as you probably could easily do. So this would be x squared plus x minus x plus x plus x minus 1 minus 1 plus 1. And when you combine everything, this is what you get algebraically. You get x squared plus x, take away 1. Next one, I'd have negative x squared plus x squared plus x minus x plus 1 minus 1. And when you combine all your like terms, all you're left with is negative x, or minus x. So this is the algebraic representation of the answer.